In our last video, we looked at the transformations up and down and left and right, and we saw that those were created by adding or subtracting numbers either outside the function or inside the function. What we're going to look at in this video is what happens if we have a function g of x and it is some known function, some function that we already know with a minus sign in front of it. For instance, let's say that we have a function, g of x, which is equal to negative x squared. We know already what the graph of x squared looks like. So we can graph our basic function here, our known function, y equals x squared. And we know if we plot 3 points, we know we have 0, 0, 1, 1, and negative 1, 1. And we know from our lesson on the basic graphs that that's going to be a parabolic shape. Now, what we're looking at in this lesson is what does this negative out front of the graph do? What it does is it takes every single one of our points, our ordered pairs on the graph of x squared, and then takes that number and makes it a negative. So if I have the point 1, 1, it becomes 1, negative 1. And if I have the point negative 1, 1, it becomes negative 1, negative 1. And then a negative 0 is still just 0. So every single one of these ordered pairs on this graph becomes an ordered pair down here. And we see that our graph of g of x equals negative x squared looks like this. Notice that this is a reflection, and the axis that we are reflecting over, the axis that is acting as the mirror, is this axis, which is the x-axis. So what this gives us is a reflection over the x-axis. And that's going to happen every time. So we can add that to our list of rules here. A negative outside of the function is a reflection over the x-axis. And notice that this negative is outside the function, just like up here, the plus c and the minus c were outside the function. We had a change in our y value. We are changing in the y direction. The reflection is over the x-axis. The change is in the y direction. Let's look at another example of that. Let's say that we have our function, g of x is equal to negative cube root of x. And what I'd like you to do is identify the basic function that this looks like. Sketch that basic function, plotting at least 3 points. List the transformation, and be specific about direction or axis, and then sketch g of x. So I want you to pause your video, try this example, and then turn the video back on. Okay, so we see that our basic function is the cube root of x. So we have y equals the cube root of x. And then I sketch that. And if I remember my basic functions, I remember that the cube root is the one, and if I plot my 3 points, the cube root is the one that curves out this way and then back over here at -1, -1, back over in this direction. And I meant to do that in blue to match the cube root, so I'll just go ahead and draw over it in blue. All right, so that's our basic original function. And then we see that our change here is this negative in front of the function, outside of the function. So that tells me that I have a reflection over the x-axis because I'm changing all of my y's. So when I sketch g of x, this point reflects down to here, 0, 0 stays where it was, and this point reflects up to -1, 1. And then I just recreate that shape. And that's what g of x looks like. And this one was my basic function y. Okay, hopefully you got that one okay. Let's look at what happens if my function g of x is f of -x. And what we're going to see on this one is that the negative is now inside of the function. So let's say we have g of x equals the square root of -x. And notice that the negative is inside of the square root. So it is being affected by the function. So we're going to list our basic function. In this case, y equals the square root of x because we have a square root. And we're going to graph that function. And we know that the square root is the only one that has the domain from 0 to infinity, because in the real number world, we cannot take the square root of a negative number. And if we're graphing, we're in the real number world. So we have 0, 0, and we have 1, 1. The square root of 1 is 1. And we know that our basic shape looks like this. So this is my graph y equals the square root of x. Now, what we're doing here is we're taking every number and we're putting a negative in front of it. For instance, if x is 4, then we put a negative and we take the square root of -4. Well, we can't do that. We can't take the square root of a negative number in the real number world. But what if I started with a negative number? Then I would be taking the square root, this is g of x, I would be taking the square root of a -4, which is the square root of 4, which of course is 2. So what we're going to see here is that when we do the negative in front of the x inside, it gives us a reflection over the y-axis, and we have a change in our x direction. It is reflecting in the x direction because the negative is inside of the function. So we're going to see that our transformation is a reflection over the over the y-axis. Okay, and that's going to happen every time. If we have a negative inside of the function, we have a reflection over the y-axis. So we follow the same thing we had up here. The negative outside the function is in the y direction. And if it is inside the function, it is in the x direction. My x's are changing, left to right. I'm going to have you go ahead and practice one here. Let's say that we have the function y equals negative x cubed. I'd like you to go ahead and write the basic function. Graph it. List the transformations. And then graph with the transformation. Pause the video and try this. All right, and what we see here is that our basic function looks like y equals x cubed because of the x cubed here. And if I graph that, I have 0, 0. 1 cubed is 1, negative 1 cubed is negative 1, and this is the one that curves upwards. Like that. All right, then, so this is y equals x cubed. And I keep graphing it in black when I mean to do it in blue. So this is y equals x cubed. All righty, now we list our transformation. The negative is inside of the function, so that is a reflection because it's a negative. And it is changing the x, so it's going back and forth in this direction, on the x direction, so that tells me that this axis is acting as the mirror. So it is a reflection over the y-axis. And then when I draw my graph, 0, 0 stays where it is. This point reflects over to here at negative 1, 1. This point reflects over to here. And then I just recreate my same shape. And this is the graph of y equals negative x cubed. In our next video, we're going to look at some stretches and some shrinks and see what causes that and how we graph those.